Welcome to another aspect on gas law. Welcome to another aspect on gas law. Now, we have a lot of gas equation or the gas law. Now, the first one we'll be talking about is the Boyle's law. Boyle's law. Boyle's law states that the volume of a fixed mass of gas is inversely proportional to its pressure at constant temperature. And that shows, if you are talking about the Boyle's law, that shows that as you know, it is the volume is inversely proportional to the pressure. It shows that as the volume increases, the pressure decreases. Or let me say, as the pressure increases, the volume decreases. Or as the pressure decreases, the volume increases. So that is inversely proportional. So from this equation, you can have V to be equals to, now if you change this, proportionality to equals to be K over P. Then if you cross multiply from this K, make K the same formula. K will be equals to PV or VP, anyhow. So if you now have more than, this is the equation, K is equals to PV. But if you have more than one gas, if you have gases, then you can have it to be P1, V1 equals to P2, V2. Even if you have three gases, then it can still be equals to P3, V3. So make sure that this equation stands. So this is Boyle's law. Number two, we have Charles' law. Charles' law states that, yes, according to Jackie Charles in 1787, it states that the volume of a given mass of gas states that the volume of a given mass of gas is directly proportional to its temperature at constant pressure. So that shows that we are talking about directly proportional. So it's directly proportional. It means that you have the volume to be directly proportional to temperature like this. Now, if volume is directly proportional to the temperature, so if you want to remove the proportionality constant, we have V to be equal to KT. So making K the same formula here, K will be equal to V over T. So you have V, K to be equal to V over T, that is volume over T. So V here is volume. P is what? Is pressure. And T is temperature. So here, under Charles' law, as volume increases, the temperature increases. Or let me even say, as temperature increases, the volume increases. Or as temperature decreases, the volume decreases. So that is the concept. Now, if you check this very well, if you have more than two gases under Charles' law, you have V1 over T1 to be V2 over T2. Even it can be equal to V3 over T3. Even to V4 over T4. So it depends on the number of gases we have. Next one. The next one we can talk about the pressure law. The pressure law, or we call it Hamilton's law. So let's write the pressure law. The pressure law, or we call it Hamilton's law. Now this states that the pressure, this states that the pressure of a given mass of gas, the pressure of a given mass of gas is directly proportional to its temperature at constant volume. Now let's see. Since pressure is directly proportional to the what? To the temperature. So we have the pressure directly proportional to the temperature. So pressure will be equals to Kt. So K will be equals to P over what? Over T. We remove the proportion. If you have more than one gas, you have to be P1 over T1 to be P2 over T2, etc. So it depends. So if you want to solve any equation, you use the one at which you are given. So that's it. Number 4. We have the ideal gas equation. The ideal gas equation, this describes the 4 terms. That is, it combines both the Charles law, the pressure law, and the Boyle's law. Yes, you have to know the combination. Yes. You have to know it very well. Now, what is the ideal gas equation? The ideal gas equation mathematically, it says PV is equals to nRT. PV is equals to nRT. Now don't forget that your P is pressure, your V is volume, your N means number of mole. Then our R means gas constant. Then our T means what? Temperature. Now take note. We all know that we have what is known as STP. So at STP means standard temperature and pressure. Your temperature has a constant value, which is 273 Kelvin. Yes. And at the same time, don't forget the value of your R here, your molar constant. Your R has a value because it's a constant. It's a molar constant. It's a gas constant. So it is 8.314 joule per mole per Kelvin. Yes, so with this, you can be converting this to other ones. Or you use 0.08205 liter ATM per mole per Kelvin. So you can use this 0.08205 liter ATM per mole per Kelvin. And these are the formulas. And these are the constant values for the gas constant, temperature, And at the constant pressure, we can have 1 atm or 760 millimeter per mercury. Now you have to know all these formula, all these constants, because there are some times whereby you'll not be given, then you have to use it. You have to use it so that you'll be very, very fast in what? In thinking. So you can have 1 atm, or sometimes we even can have it to be 101.325 kilopascal. It can also be in the pascal, so it depends. Now, when you are talking about the constants of all these ones, if you say PV is equal to NRT, now what of if you have what's it called it? What of if you have if your N is 1 mole, you have it to be 1 mole. So that means we have PV to be equal to what? RT. So if you are talking about 1 mole gas, then PV will be equal to what? RT. Please take note. So we can proceed. Now, from this equation, we can still generate the combined formula that says P1 V1 over T1 to be equal to P2 V2 over T2. Because at 1 mole, don't forget I said your R is gas constant. So R can be PV over T. So R can be PV over T. And since this is the constant, so if you have more than 2, you can have it to be P1 V1 over T1 to be equal to P2 V2 over what? Over T2. And number 5. We are talking about number 5. Don't forget we have a constant volume as well. If you are given a volume can be 22.4 dm³ as well. Or you have it to be 22,400 cm³. Volume also have a constant volume. So this one 0.825, you understand? atm, dm³. You can also have it to be 0.825. I'm talking about the gas constant. You can also have it to be 0.08205 atm dm³ per Kelvin. So it's also part of the word, part of the formula. And let's go with another one. Number 5. Number 5, let's talk about the Gauss law. The Gauss law of diffusion. The Gauss law of diffusion. Now, the Gauss law of diffusion states that the rate at which gas molecules diffuse at constant temperature and pressure is inversely proportional to the square root of its density. Again, it states that the rate at which the gas molecule diffuse at constant temperature and pressure is inversely proportional to the square root of a density. That is Gauss law of diffusion. And mathematically, we can say the rate is inversely proportional to the square root of its density. Now, if this happen, don't forget that if your I can become k over square root of d, when we remove the proportionality constant, then k will be equal to r square root of d. And if this happen, if it is more than 1, we have it to be r1 the square root of d1 to be equal to r2 square root of d2. Now, there's a formula that people normally derive from here. But if you don't know the formula, you can just use this one straight up. And the formula says r1 over r2, which will be equal to square root of d2 over square root of d1. How did I know that this will happen? If you cross multiply this, you observe that r1 will come and multiply square root of d1, which is the same thing with this. Then r2 will come and multiply square root of d2, which is the same thing with this. So that's it. And don't forget, I can proceed with this formula. This formula, rate is inversely proportional to the time. Like, rate is inversely proportional to time. So, if where there is r1, there will be t2 because it is inversely proportional. So here, r1 over r2 will be equal to t2 over t1. That's time. And don't forget that the r1 over r2 is equal to square root of d2 over square root of d1. Now take note. Rate is inversely proportional to the what? To the time. Now at the same time, we have density. Density to be equal to mass over volume. So that means density is directly proportional to mass, but density is inversely proportional to volume. So our formula will becomes r1 over r2, which is equal to t2 over t1, and it will be equal to square root of d2 over square root of d1, which can still be equal to. Don't forget that density is directly proportional to mass. So where there is m2, d2, we have m2. And where there is d1, we have what? m1. But it will now be equal to square root of v1 over square root of v2 here. Because you can see that density is inversely proportional to what? To volume. So where there is d2, we have v1. Where there is d1, we have what? We have v2. But because it is directly proportional to mass, so where there is d2, we have m2. Where there is d1, we have what? m1. So that's it. So therefore, let's denote this. We have r base rate of diversion. Rate of diversion. We have t to be time taken. Time taken. We have d to be density. We have v to be volume. We have m to be molecular mass. That's all. So these are the formulas under Gram's law of diversion. But this formula is very exceptional to use. Whenever you are talking about the Gram's law of diversion, you have to be very patient. Yes, you have to be very patient. It's very dimensional to use. So please, you have to be very patient. So, the next one, let's talk about the number 6. Let's talk about number 6. Number 6 law. Number 6. We have Avogadro's law. Avogadro's law. Or let me see, the Avogadro's hypothesis. What is Avogadro's hypothesis? Avogadro's hypothesis states that equal number of gases under constant temperature and pressure. Under constant temperature and pressure contains the same number of molecules. If you check this Avogadro's law very well, some even says Avogadro's law states that equal volume of all gases, that equal volume of all gases. Yes, you can put the equal number of volume. Equal number of volume of all gases under the same temperature and pressure contain the same number of what? Of molecules. That is equal number of volume of all gases under the same temperature and pressure contain the same number of what? Of molecules. That's Avogadro's law. That shows that the volume is directly proportional to what? To the number of molecules or number of mole. So removing the proportionality constant, we have it to be this. And making K the sum formula, that's V over what? Over N. If you have more than 2, you have V1 over N1 to be V2 over N2 according to Avogadro's hypothesis. Number what now? Number 7. Number 7. Let's talk about the Dalton's law. The Dalton's law of partial pressure. The Dalton's law of partial pressure, this states that the pressure of a mixture of gases, simply is the sum of the partial pressure of the partial pressure of the individual components That's what they call the Dalton's law of partial pressure. And what is it? This is it. If you have a substance A, B, or you have gas C like this, then you all believe with me that these gases will process, let's say they have like, if you mix gas A plus gas B plus gas C to give you the total what? The total gas. Let's say gas D, gas T, the total. Now the total like this, the pressure of A plus the pressure of B plus the pressure of C will give us what? The total pressure. That's PT. Now, take note. We have what you know as the mole fraction. The mole fraction of the substance A will be equal to the number of mole of A over total number of mole. The mole fraction of B will be equal to number of mole of B over total number of mole. The mole fraction of C will be equal to number of mole of C over total number of mole. Meanwhile, this one can be proceed to be the mole fraction of A can be equal to number of mole of A over the total number of mole is those number the number of mole of the substance that are included in the reaction. Number of mole of A plus number of mole of B plus number of mole of C. The mole fraction of B will be number of mole of B over number of mole of A plus number of mole of B plus number of mole of C. So if you have 4 substances in the reaction, maybe you have substance A, substance B, substance C. Even if you have up to D, the total will be at the denominator. So the mole fraction of C will be equal to number of mole of C over number of mole of A plus number of mole of B plus number of mole of C. So this is how to do the mole fraction. And at the same time, if you are talking about the other aspects, like the one for the pressure. Now, if it is for the pressure, let's talk for the pressure. And it is for the pressure to process the same formula. So I just want to show you so that you can see. And let us see. Now, for the pressure now, let me go use another book entirely. Now for the pressure, if I can say that the mole fraction of A is number of mole of A over the total number of mole. So if it is for the pressure as well, so the pressure will be the mole fraction of A will be pressure of A over total pressure. The mole fraction of B will also be equal to the pressure of B over total pressure. So the mole fraction of C will be equal to pressure of C over total pressure. So the mole fraction of A can also be pressure of A over pressure of A plus pressure of B plus pressure of C. That's total. So the mole fraction of B can also be pressure of B over pressure of A plus pressure of B plus pressure of what? Of C. So the mole fraction of C will be equal to pressure of C over pressure of A plus pressure of B plus pressure of what? Of C. So this is it. So you have to check this. So I will not bother to explain the Raoult's law, because the Raoult's law also explain these similar things. So Raoult's law is also similar to the Dalton's law of partial pressure. They both explain, they said the partial vapor pressure is equal to the what? To the mixture of the what? Of the individual pressure. So multiplied by the mole. So that is what the Raoult's law also explains. So I may not bother to explain the Raoult's law. Now the next aspect we'll be looking at is the root mean square velocity. So this is where I'm going to end this aspect. The root mean square. The root mean square. Now, what is root mean square? Pressure. The root mean square velocity that we have. Now, when you're talking about the root mean square velocity, then you have to recollect what we mean by velocity. Don't forget that velocity is measured in meter per second. And once velocity is measured in meter per second, then don't forget that we can have it to be, let's say you have, let me go to that aspect. The aspect of root mean square velocity. Now, if you're talking about the root mean square velocity, then take note. We have the root mean square velocity, we have different formulas. Root mean square velocity. We can use U to denote it. So it's equal to square root of 3RT over M. Square root of 3RT over M. Now we are saying square root of 3RT over M. Before I proceed, under this aspect, the N means number of mole. Don't forget. And the P means pressure. P means pressure. And this symbol means the mole fraction. Mole fraction. So you'll be given in the equation. But if you're not given, if you're asked to find, these are the formulas in which you can use to find the what? the mole fraction of any given mixture. So that is it. Now, if you are asked to find the root mean square velocity, we have it to be square root of 3 RT over M. But don't forget that PV can also be equal to what? nRT. And I told you that when N is 1 mole, then you have PV to be equal to RT. So since PV is RT, so you can have the root mean square velocity as well to be equal to square root of 3 PV over M, because our RT here can be equal to what? PV. Now, but don't forget that we can also have another formula that says from density. Don't forget that density is equal to mass over volume. Now, if density is mass over volume, from this equation, I can say the root mean square velocity is square root of 3 multiplied by. If density is equal to mass over volume, what is volume over mass? Volume over mass will be 1 over density. Check it out. 1 over density will be volume over mass. So we have P multiplied by volume over mass here. So this volume over mass here, from this equation, is what? Is 1 over density. So the root mean square velocity can also be square root of 3P multiplied by 1 over density. So if you take it together, we have it to be square root of 3P over density. So P is pressure, T is temperature, M is mass, then D is density, then you have, that's all. Those are the things we have. Now, you have to take notes this aspect very well. You have to take note this aspect very well, because it's very, very dangerous. Now, this aspect will be done, some people do it under chemistry, but take note, if you are given this in gram, if you are given in gram, like if you are given mass of a substance, maybe 20 gram, you are given in gram, you have to divide by 1000. You have to divide by 1000. Or let me say, the mass you'll be given is the molar mass. This one is the molecular mass. So the molecular mass will be 20 gram per mole. So if you are given in gram like this, like 20 gram per mole, then you divide by 1000. So if you divide by 1000, so your answer will be converted to kilogram per mole. But if you are given the molar mass in kilogram per mole straight, then use it like this. But if you are given in gram per mole, you have to divide by 1000 before you can use it in the equation. So that is all about this aspect. Now, I believe we have done wonderfully well today. Yes, I believe we have done wonderfully well. Now, I have an assignment, and I want you to just give an answer to this at the comment section. Give an answer to this at the comment section. Now, what is the question? The question is, this equation, P plus A over V squared minus into bracket V minus B is equal to RT. This equation is for what? This equation is for which law? It's for which law? Let me say yes, it's for which law? We have the answer to be. Or let me say, no, don't let me say the answer. So let me know what is the answer to this equation. Sometimes we put N here. It is PV equals to nRT. Sometimes there is N here. So the answer, option A. I'll just give you two options. We have the Charles ideal gas equation, ideal gas equation, and we have the van der Waal ideal gas equation. So let me know the one that is equal to this between the two. So thank you very much for this class under the gas law. Thank you very much. We're going to continue the next episode. Like, comment, and subscribe for more videos. God bless you. Thank you.